Hey everyone. Today we're going to look at one of my favorite questions. It's called body strings. I believe this question has shown up at Google. I really enjoy asking this question and I've used this question several times because it highlights a very important part of problem solving that I'm going to discuss in a moment. Let's look at what this problem is about. So essentially you're given two strings A and B, and the question asks you if you can perform one swap in A so that the result equals B. So let's take a look at some of the examples that they have here. So in the first example, we have string A equals AB, and if we swap these two characters here, we're going to get BA, and BA is equal to the string B. So what we've done here is that we have made one swap in A and the result is equal to B. So the output here is true. Let's look at the second example. So here in A is AB, and in this case, we can also just perform one swap here. There's only two characters. So if we turn this into BA, BA is not equal to the input B. So we have to perform one swap. And once we do that, the result is no longer equal to B. So in this case, we would say the answer is false. Let's look at the third example. The third example is interesting. A is equal to AA. And so if you swap the two A's, you're still going to get AA. And AA is equal to the input B. So in this case, the answer is true. Now let's look at the fourth example. So in the fourth example, we swap these last two characters and we're going to get, and this result is equal to B. So the output here is true. Let's look at the fifth example. The fifth example, A is an empty string. So there's really nothing to do here, and no operations in A is going to equal to input B. So the answer here is false. So a couple of things that are obvious and we should realize immediately is that the prerequisite here is that the length of A should be equal to B to begin with. Because if the lengths were not equal to begin with, then there's no way that A is going to be equal to B despite any transformations you perform in A. A few other things to note from the problem definition: A and B consist only of lowercase letters. Now, the reason I like this question is because just take a look at how many examples you've got here. You have 5 examples. That usually doesn't happen. Really, what's going on here is that you're given some additional information that you're supposed to infer from these examples. Normally, in most questions, you would get only a single example or 2 examples at most, and it's up to you to arrive at more examples. But in this case, you have 5 examples. And right off the bat, let's notice that there's 2 cases here. You have this example here where A is not equal to B to begin with, right? And that's also the case at example 4. But in these 2 examples here, A is equal to B to begin with. So both the inputs are already the same. And it's worth looking at these examples separately. So let's jump into some examples that I have made to animate what's going on here. Here we have an example that's where A is not equal to B. And here we have an example where A is equal to B to begin with. And in both cases, the answer is true. Let's see how the swaps happen in both these examples. In the first example where A is not equal to B, you can see that these 2 characters in A are going to be swapped to yield B. In the second example where A is equal to B, you can see that the first and last character can be swapped to yield A equals B. The reason we want to solve these separately is because in this case, A is already equal to B, and we want to maintain this invariant that A is already equal to B. While in this case, A is not equal to B, and we want to find out if it's possible to perform a single swap and turn A into B. Once we've broken the problem down into these 2 separate cases, We can solve for these cases separately. So let's take a look at the case where A is not equal to B. Now, given that both strings are of the same length, all we need to do here is to traverse these strings character by character and note where each character is matching or not matching. When we find a mismatch, you can take note of that. So at this point, we have two indices where we've noted mismatches. If you had more than 3 mismatches, then you already know that the answer here is false. Additionally, you need the symmetry where the two characters at the mismatch indices have to match as well. Once these symmetries have been established, now you know you can perform the swap. Let's take a look at that again. So you just traverse the strings, capture the mismatch indices. Once you have the mismatch indices, you know that you need a symmetrical relationship or a symmetrical equivalence to then perform the swap. And that's it. And in the second case where A is already equal to B, we need to make sure that any transformation we perform on A continues to maintain that invariant where A equals B. So we have two kinds of swaps we can perform. We have a harmless swap that does not change anything, and a harmful swap would make A not equal to B anymore. So what is it that can enable us to perform a harmless swap when A is already equal to B? It's quite straightforward. You need a duplicate element in A to perform a harmless swap. A harmful swap would mean swapping two non-equal elements. Let's take a look at the code here. So we start off with a prerequisite. If the lengths are not equal, we return false. This is the case where A is equal to B. And this is the case where A is not equal to B. We handle these separately. When A is equal to B, we have a set called scene that simply adds characters in A into the scene. And if we've already seen a character, we know that a duplicate exists and we return true. If we finish traversing A and we've never found a character in our set a second time, we return false. This is a simple duplicate check in A. When A is not equal to B, we maintain a list of pairs where we add the concatenation of characters when the indices don't match as we are traversing the strings. So let's say you have these two strings A and B here, and if there's a match, we do nothing. But if there's a mismatch, let's say at this point, then we take the characters along this mismatch, let's say they were XY, and we concatenate them and we store it in pairs. If we find another mismatch at this point again, we repeat that process. Let's say that at this point the mismatches had Y and X here, so we would store YX in our pair list. Now it's important that this pair list have a length equal to 2. This means that we had 2 mismatches exactly. If we had more than 2 mismatches, we already know that the problem cannot be solved with exactly one swap. Finally, we check if pairs of 0 is equal to the reverse of pairs of 1. That's what this line here does in Python. So in this case, xy is equal to the reverse of yx. Here is where we perform that symmetric equivalence that we spoke of earlier, where x is equal to x here and y is equal to y. A simple way to check that is using reverse. And that's it. This is the whole problem. It's really easy when you break it down into different examples and different cases. And you can see that despite it being an easy problem, there haven't been a lot of accepted solutions. And I think that most folks just get stuck at a point where they don't fully digest these 5 examples and break it down sufficiently to solve it in these 2 separate cases that we've shown here. Okay, so I hope you enjoyed that and hope you try this problem out on your own. I'll put a link down to the code that I have on GitHub, as well as the link to the LeetCode problem itself. Thanks for watching.